Physics Part 396. From the binding energy per nucleon curve, we see that the binding energy per nucleon for light nuclei, such as hydrogen, is low, but if two light nuclei are made to fuse together, they may form a new heavier nucleus which has a higher binding energy per nucleon. It will be more stable than the two lighter nuclei from which it was formed. Because of this difference in stability, a fusion reaction such as this will release energy. Although fusion reactions are source of solar energy, we are at present unable to duplicate this reaction in a controlled manner on Earth. This is because the nuclei involved in fusion have to be brought very close together, and conditions of extremely high temperature and pressure similar to those found at the center of the Sun are required. Reactions requiring these conditions are called thermonuclear reactions. Some fusion reactions involving hydrogen isotopes have been made to work in the Joint European Torus (JET), although not yet in a controlled, sustainable manner. In 2006, an international consortium agreed to undertake the ITER, International Tokamak Engineering Research Project, which is designed to produce up to 500 MW of fusion power sustained for over 400 seconds by the fusion of 2H minus 3H mixture. Construction on a site in the southern France will take 10 years. We've got a section summary for section 13.7, 13.8, 13.9, 13.10, and 13.11. The summary says, number one, the mass defect of nucleus is the difference between the total mass of separate nucleon and the mass of nucleus. Number two, Einstein's mass energy equivalence reaction E is equal to mc square. Number three, the binding energy of a nucleus is the energy needed to separate completely all its constituent nucleons. Number four, the binding energy per nucleon is a measure of stability of a nucleus. A high binding energy per nucleon means nucleus is stable. Nuclear fission is splitting of a heavy nucleus into two smaller, lighter nuclei of approximately equal mass. Nuclear fusion is the joining together of light nuclei to form a larger, heavier nucleus. We've got some section questions, and number one, calculate the mass defect, the binding energy of the nucleus, and the binding energy per nucleon for the following nucleus. Hydrogen 3, nuclear mass, and then zirconium 97. Zirconium 9740 ZR, nuclear mass is 97.09801 U. C. Radon 22286 Rn, nuclear mass is 222 U. And proton mass is 1.00728 U. Neutron mass is 1.00867 U. Question number 2. One possible reaction taking place in the core of a reactor. For this reaction, calculate the mass in each side of the equation. Calculate the change in mass after fission has taken place. Calculate the energy released per fission of uranium-235.